Hello everybody, this is lesson 20 of the lecture Macroeconomics. I will discuss the slides 96 to 127 of chapter 4, the Keynesian model. In this lesson we will analyze demand-side shocks under the assumptions of the Keynesian model. So what happens under the Keynesian assumptions if households reduce their consumption demand? In section 3.2.3 we have already analyzed the consequences of demand-side shocks under the assumptions of the neoclassical model. We found that they have no destabilizing consequences for the economy. The question is now whether this is also the case under the assumptions of the Keynesian theory. To remember, if households expect a deterioration of the economic development which causes a higher probability of getting unemployed, it is rational for every household to reduce consumption and increase savings, to have a financial safety cushion in the case they become actually unemployed. But what are the consequences now of this seemingly rational behavior? Let's assume that households increase their savings ratio from 50% to 75%. Be aware that this necessarily implies a reduction of the consumption ratio from 50% to 25%, since the consumption ratio and the savings ratio must add up to 100%. Let's start the analysis again with a general market equilibrium where GDP equals the level of 30 units, which corresponds to 1, 2, 3, 4, 5, 6 little quarts. At this GDP level, the market for goods is in equilibrium. Consumption equals 30 units of GDP times the consumption ratio of 50%, what equals 15 units consumption, or the length of 3 little quarts. Since the initial investment level equals 15 units, total demand for goods equals 30 units. 15 units consumption demand plus 15 units investment demand. So total demand does in fact equal the GDP level of 30. Now 50% of GDP is not consumed but saved. As a result, savings equal the initial 50% savings ratio times 30 units of GDP, what equals 15 units of savings. The interest rate adjusts in a way that investment equals savings, which means investment equals 15 units. This corresponds to the assumption that the initial investment goods demand from firms equals 15 units. So it's indeed an equilibrium on the market for goods and the capital market. How does the increase of the savings ratio to 75% change this initial equilibrium? The increase of the savings ratio to 75% causes a decrease of the consumption ratio to 25%, as already mentioned. This does now change the slope of the consumption function. The slope of the consumption function gets flatter, so it moves downward. From a GDP level of 30 instead of 15 units, now only 7.5 units, what equals 25% times 30, are consumed. As a result, you also have to change the slope of the total demand curve, since the total demand curve corresponds to the investment demand plus the consumption demand. So if the consumption demand curve gets flatter, the total demand curve gets also flatter. This does now shift the intersection point with the 45-degree line from this position to this position. The new equilibrium level of GDP is now equal to 20 units. At GDP level of 20 units, 25% is consumed, which equals 5 units, the length of one little quad. And then we have still 15 units investment demand, which adds up to a total demand level of 20. But what happens now on the capital market? Will the higher savings ratio of 75% now actually cause an increase in savings such that the investment demand for goods grows and perhaps compensates for the reduction in consumption demand, as we have it observed under neoclassical assumptions? Actually, this does not happen. Instead, the reduction of GDP from 30 units to 20 units causes savings to stay constant despite the higher savings ratio. Numerically, 50% times 30 equals 15, and a savings ratio of 75% times a GDP level of 20 equals also 50. This means that savings do not grow despite of the higher savings ratio, such that investment can also not grow to compensate for the lower consumption level. So the whole adjustment process ends in a stable equilibrium with a significantly lower GDP level of only 20 instead of 30. So this analysis shows, since under Keynesian assumptions, supply of goods does always adjust to the demand for goods, a reduction of demand causes a reduction of GDP. So if households expect a deterioration of the economic development and reduce their consumption demand, a deterioration of the economic development will actually occur because they have expected it. Such a phenomenon is called self-fulfilling expectations. What is expected does actually happen because it is expected. So let's sum up the whole adjustment process in verbal terms. A deterioration of household expectations on the economic development increases the savings ratio and decreases the consumption ratio, respectively. This reduction of the consumption demand causes a reduction of the supply of goods and hence a reduction of GDP, which equals household income. So household income falls also. This initiates a negative multiplier process. Household income shrinks further because of lower household income. And consequently, consumption demand contracts even further, so that total supply of goods contracts again, and consequently household income decreases again, so that consumption demand contracts once again, and so on and so on. We have already discussed the working of the multiplier process. The negative multiplier process keeps on until the decreased consumption demand plus the unchanged investment goods demand equals again GDP, respectively. Since GDP falls, savings stay constant despite of the higher savings ratio. Consequently, investment stays also constant. So, contrary to the neoclassical model, investment stays constant and cannot compensate for the lower consumption demand. The whole economy stays stuck in a new equilibrium with significantly lower level of GDP. Let's now analyze what would happen if the demand side shock is caused by a sudden reduction in investment demand. So, what happens under Keynesian assumptions if firms reduce their investment demand? In section 4.1.2, we've seen that under Keynesian assumptions, the investment demand of private companies depends positively on the expected return. If the expected return increases, investment demand increases too. And if the expected return decreases, investment demand decreases too. So if companies now expect a deterioration of the economic development, which will cause a lower return on investment, it seems to be rational for every company to reduce investment to those investment projects only with returns high enough to cover the interest costs. What happens if firms practice this seemingly rational behavior? Let's assume that firms lower their investment from 15 to 5 units. We start this analysis again with a general market equilibrium where GDP equals a level of 30 units, as we did to analyze the consumption shock. So we have to reduce the demand for goods and the demand for investment credits by 10 units, which corresponds to the length of two little quads. So this curve, the demand for goods, shifts downward by the length of two little quads, 1, 2, parallel downward shift to this level, and at the same time we have to shift the credit demand curve for investment goods to the left by the length of 1, 2 little quads. The same interest rate as before, now 2 little quads less investment credit demand is exerted because we need 2 little quads less investment credit demand to buy investment goods. Both demand curves shift at the same time, so we must shift these curves simultaneously. As we can observe now, the resulting level of investment demand equals now 5 units only. That corresponds to our assumption that investment falls from 15 units to 5 units. The intersection point shifts downward to an equilibrium level of 10 units GDP. So, as a result of a reduction of investment demand by 10 units, total GDP falls from 30 units to 10 units. What happens now on the capital market? The reduction of investment credit demand would cause, taken for itself, falling interest rates if the savings level would stay constant. However, given the lower equilibrium level of GDP, 10 units only, savings will now fall to a level of 10 GDP units times the savings ratio of 50%. And this results to a savings level of only 5. As a result, the interest rate stays constant at the level of 2.5%, since the intersection point of the new savings curve, this curve, and the new investment credit demand curve, this curve, lies here at the same level as before, 2.5%, such that investment credit demand equals 5 units too. So the whole adjustment process ends again in a stable equilibrium with a significantly lower level of GDP. We started with a GDP level of 30, and at the end of this adjustment process, GDP equals 10 units only. This analysis shows, under Keynesian assumptions, where the supply of goods does always adjust to the demand for goods, a reduction of demand causes a reduction of GDP. If firms expect a deterioration of economic development such that they fear a decrease in investment return, they reduce their investment demand for goods. As a result, their expectations finally realize. Consequently, what they have expected, namely a deterioration of the economic development, does actually occur because they have expected it. Consequently, firms too can cause self-fulfilling expectations. What is expected does actually happen because it is expected. To sum up, a deterioration of the expectations of firms on the economic development causes a reduction of the investment demand of firms. This reduction of investment demand causes a reduction of the supply of goods and hence a reduction of GDP, which equals household income. This initiates the by now well-known negative multiplier process. Household consumption shrinks further because of lower household income. Consequently, consumption demand contracts even further, so that total demand of goods contracts again too, and consequently household income decreases, so that consumption demand contracts once again, and so on and so on. This negative multiplier process keeps on until the decreased consumption demand plus investment goods demand equals GDP. Since GDP falls, savings fall also, because savings equal the savings ratio times GDP. Therefore, the interest rate stays constant compared to the initial situation. As a result, the investment credit demand stays on its lower level. So the whole adjustment process ends in a stable equilibrium with a significantly lower level of GDP. So far we have neglected the labor market. But what consequences do these type of demand-side shocks have for the Keynesian labor market? As the preceding section has revealed, a deterioration of consumer and/or investor expectations concerning the economic development can actually cause a recession, a severe decline in GDP. A decline in GDP means, however, that firms also reduce their demand for production factors, and notably the demand for labor. If wages are not flexible but fixed by collective bargaining agreements, labor supply stays unchanged. If labor demand slumps while labor supply stays unchanged, unemployment will emerge. This kind of unemployment is ultimately caused by a reduction in the demand for goods, and not by too high wages, as in case of neoclassical unemployment. It is therefore called Keynesian unemployment. Let's analyze this adjustment process based on the production module of the Keynesian model. Under the assumptions of the neoclassical model, which we have discussed in chapter 2.1, the supply of goods depends on the equilibrium labor input determined on the labor market, where the wage rate adjusts until labor supply and labor demand are identical. The resulting labor input is then used to produce GDP, which is then supplied on the market for goods. The resulting level of GDP is called normal capacity GDP or full employment GDP. This means, under neoclassical assumptions, the causality comes from the labor market. The labor market decides how much labor input is used to produce GDP. So the supply of GDP depends on the labor market equilibrium, and not vice versa. This is the neoclassical version of the production module. Under the assumptions of the Keynesian model, firms adjust in the short run their production of goods to the demand for goods. Therefore, they will also adjust their labor demand to the demand for goods in the short run. Consequently, in the short run, the labor demand of firms is, under Keynesian assumptions, not determined by the labor market equilibrium wage rate. It is determined by the demand for goods. Starting with this demand, we use the production function to calculate the necessary labor input, which then corresponds to the Keynesian labor demand. Consequently, the Keynesian labor demand curve, this vertical line here, depends not on the equilibrium wage rate, but on the level of the demand for goods. Therefore, we write now the demand for goods as the basic argument of labor supply in this bracket of the labor demand function. Only if labor demand for goods equals full employment GDP, Keynesian labor demand will equal the full equilibrium input of the neoclassical model. If, however, the demand for goods falls below this full employment level of GDP, for example, to this level, Keynesian labor demand will be lower than the equilibrium labor demand of the neoclassical model. If the real wage rate is downward fixed by collective bargaining contracts to this long-run market equilibrium level, the resulting unemployment is called Keynesian unemployment. We know from section 4.2 that also the opposite can happen. The demand for goods can grow above full employment GDP. In this case, Keynesian labor demand will be higher than the equilibrium labor input of the neoclassical model. This will be now our labor demand curve, our Keynesian labor demand curve. To receive this additional amount of labor, firms must pay higher wages than the collective bargaining wage rate. In economic booms, workers receive typically so-called overtime premiums. Collective bargaining contracts allow such increases of wages. Therefore, wages will grow until households supply the additional amount of labor needed by firms to produce the higher GDP level. The resulting situation is then called Keynesian overemployment. So it's important to remember that the Keynesian model explains not only Keynesian unemployment, but also Keynesian overemployment. Consequently, the Keynesian theory implies that the labor market depends on the business cycle fluctuations of GDP. A negative demand-side shock causes a downswing of GDP and consequently a reduction in labor demand with the consequence of Keynesian unemployment. A positive demand-side shock causes an upswing of GDP and consequently an increase in labor demand with the consequence of Keynesian overemployment. So consequently, the unemployment rate and GDP should be negatively correlated. If GDP grows caused by an economic boom, the unemployment rate should go down. And if GDP shrinks caused by an economic downswing, the unemployment rate should go up. The following diagrams show that this is actually the case. The empirical classification of business cycles follows a quite simple idea. The growth rate of the actual GDP, the green line here in this diagram, is compared with the growth rate of the moving average of GDP, the black line here in this diagram. The moving average is calculated as the average value of GDP over a time span of 7 years. If the actual GDP growth is larger than the growth trend of the moving average GDP, we are in an upswing period. If the actual GDP growth is smaller than the growth trend of the moving average GDP, we are in a downswing period. If you subtract from average growth rate of actual GDP the growth rate of the moving average GDP, we receive positive growth rates if we are in an upswing period. If we are in a downswing period, we receive negative growth rates. In this diagram, the red columns mark upswing periods as a consequence, and the blue columns mark downswing periods. In this version of the diagram, the upswing years are marked with red colored areas, and the downswing years are marked with blue areas. As we can observe, upswing and downswing periods alternate. Their duration varies between 2 and 4 years approximately. In this diagram now, the upswing and downswing periods for the German GDP are marked from the year 1960 to the year 2012. Additionally, the level of unemployment is presented by this black line here for West Germany and by the blue line for West and East Germany together. The unemployment rate is defined as the percentage ratio of the number of registered unemployed persons over the civilian labor force of a country. It is observable that the unemployment rate typically increases if the economy enters a downswing period, like here, or here, or here, here, and so on. In the blue areas, most of the time, the unemployment rate goes up. It is also observable that the unemployment rate typically decreases if the economy enters an upswing period, the red areas, like here, or here, 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 and here, for example. So, insofar, most of the time the economy behaves in the same way as predicted by the Keynesian model. However, we also observe that despite these ups and downs of the unemployment rate, there is an obvious upward trend in the unemployment rate from the year 1966 to the year 2006. This upward trend is not explained by the simple Keynesian unemployment theory we have discussed so far. As Chapter 5 will show, this development of unemployment is predicted in a quite plausible way by the so-called hysteresis theory of unemployment. The hysteresis theory of unemployment is an interesting mixture of Keynesian and neoclassical unemployment theory, as we will see. To sum up, Keynesian theory and empirical evidence shows recessions typically come along with an increase in unemployment. This leads to the question whether the government should intervene in a recession to prevent the emergence of Keynesian unemployment. As the neoclassical model has revealed, fiscal as well as monetary policy is without effect under the assumptions of the neoclassical model. This leads to the question whether this result holds also under the assumptions of the Keynesian model. We will discuss this question in the next lesson. So much for this lesson.